Hi everybody, and welcome to tonight's video where we're going to be doing some homework solutions from the problems that you did today in class. So I hope you enjoyed class without me and were able to get through these problems without too many questions. But if you have any, what I'll do here is just answer these homework problems as if I was doing them myself and just kind of narrate my answers here, so hopefully that'll help you a little bit. I'm just going to do the even-numbered problems because the solutions to the odd-numbered problems are in the back of your book, so you can look those up if you have any questions, and then you can save these until Monday if there's still something that you have a question on, and we can go over it then together. So, number 38, we're talking about the monthly cost C in dollars for international calls on a certain cell phone plan, and the linear function model for this with C of x equals 0.38x plus 5, where x is the number of minutes used. So part A asks, what's the cost, what's the total function value, if you talk on the phone for x equals 50 minutes. So it tells me that x equals 50. So it wants the total value where x equals 50. So C of 50 equals 0.38 times 50 plus 5. So I would evaluate 0.38 times 50, and that is 19. So I have 19 plus 5. So 19 plus 5 is 24. And so remember, this is the value of the function, but what's the actual question asking? It's asking what's the cost. So when I evaluate this function, I get a numerical value. I always have to translate that into whatever the question is asking. So I have to answer my question. So it asks for cost. So this isn't just the number 24, it's the amount $24. So it would cost me $24 to talk for 50 minutes on an international call. Okay, so that is the answer to part A. Part B says, suppose that the monthly bill is $29.32. How many minutes did you use the phone? So here, the function value, the cost, is $29.32. Now I want to determine the number of minutes used. And looking at my model, x represents the number of minutes used. So I'm solving for x. So the total function value is $29.32. And so now I'm going to have to determine what the value of x is. So I'm solving this equation for 29.32 equals 0.38x plus 5. So first step, to get x by itself, I have to subtract 5. And so I'll get 24.32 equals 0.38x. And now I'm going to divide both sides by 0.38. And when I plug that in, 24.32 divided by 0.38 equals 64. So 64 equals x. So how many minutes did you use the phone? Your answer to that question is 64 minutes. Okay, so always make sure you're answering the question. If I were to ask something like this on a test, I wouldn't want just x equals 64. I would want the answer to the question, which is 64 minutes. Okay, so you have to interpret what you have. Part C says, suppose that you budget yourself $60 per month for the phone. What's the maximum number of minutes that you can talk? So in this case, what I'm saying is $60 is the maximum amount. So that means that my function value, so whatever I put in here, 0.38x plus 5, has to be less than $60, right? I don't want my number of minutes, the total cost here, this function value for the number of minutes, I don't want that to exceed $60. I could say, let's say, suppose you budget yourself $60. I could call this less than or equal to, because I could spend $60. But I don't want it over 60. So 60 is anything that is less than or equal to 60. So now I can solve this for x. So I subtract 5 from both sides. So now I have 0.38x is less than or equal to 55. Divide both sides by 0.38. And so 55 divided by 0.38 equals, x is less than or equal to $144 and well, that's not, let's see, this is not a dollar amount, this is minutes. So I could talk for 144.74 minutes. That is the less than or equal to. So I have to talk for less than or equal to 144 minutes. We could just round that down so that we're using whole minutes. So we would say, what is the maximum number of minutes that you can talk on the phone? We'll call that 144 minutes. Okay. Now the next question asks, what's the implied domain of C if there are 30 days in a month? So remember, the domain is the x values, right? And the x values represent minutes. So we could, if we were being very specific, we could say that the implied domain goes from 0, right? So I could say I'm not talking on the phone at all. So 0 would be the start of my interval. And then it's minutes. So how many minutes total are there in a month? Well, we could take, there are 30 days in a month times 24 hours in a day times 60 minutes in an hour, and we could come up with that total number, right? So 30 times 24 times 60 would give us 43,200 minutes total. But I'm probably not going to talk on my phone 24/7 for an entire month, right? So let's cut that back. We'll say 30 days in a month. And we could say we're going to sleep for half of the, be tied up for half of the day. So we could cut that down to 12 if we want, and then multiply by 60. So 30 times 12 times 60 is still a ridiculous amount of minutes, 21,600. Right, so this is kind of open to interpretation. It could say for how many hours of a day that you really think you might be able to talk. But theoretically, if you were to leave your phone on, we would call this 43,200, and that would be included if you talked for every second of every minute of every day. Okay, so that is the implied domain. We could use interval notation here, and we'll include the 0 and the 43,200. Okay, so that's kind of an absurd value, but that would be our implied domain. All right, let's work on some other ones. We'll go a little bit faster now. So suppose the quantity supplied and the quantity demanded of hot dogs at a baseball game are given by the following functions. S of P equals negative 2,000 plus 3,000 P. D of P equals 10,000 minus 1,000 P, where P is the price of hot dogs. What's the equilibrium price for hot dogs at a baseball game? So to determine the equilibrium price, I'm going to set S of P equal to D of P. The equilibrium price is the price where supply equals demand. So negative 2,000 plus 3,000 P equals 10,000 minus 1,000 P. And I'm going to solve this equation for P because P represents the price, so the equilibrium price is the value of P, where these two are equal. So let's get these all together. I'm going to add, let's see, I'll add 1,000 P to each side so that I get 4,000 P over here. And then I'm going to add 2,000 to each side so that I get my 12,000 over here. And now that'll be easy. I divide both sides by 4,000. And so P, which is the price represented in dollars, is 12,000 divided by 4,000, which is 3. So P equals 3. or the equilibrium price, I should say here, is $3. Now it wants to know what's the equilibrium quantity. Okay, so what's the value of these functions at this price? And I can plug it into either one, whichever one I want to. So I'll plug it into this demand function because I think that'll be easier to evaluate. So if I take 10,000 minus 1,000 times 3. So I take the equilibrium price and I plug it into either one of my functions. Here I'll plug it into demand. So I have 10,000 minus 3,000. And so my equilibrium quantity is 7,000. So here my equilibrium quantity is 7,000 hot dogs. Okay, so when we make 7,000 hot dogs at the baseball stadium, we're selling them for $3. That is exactly where supply and demand meet. So we won't have any hot dogs left over, and we won't have overcharged. So determine the prices for which the quantity demanded is less than the quantity supplied. So here I want the quantity demanded, so that's D of P, and I want to determine where that is less than the quantity supplied, which is S of P. So I would take these two functions and determine where it's less than. So the function for demand was 10,000 minus 1,000 P, right? And the function for supply was negative 2,000 plus 3,000 P. So I'm going to try to move my P's all over to this side. So I'm going to subtract 3,000 P. I guess it doesn't really matter. And then I subtract my 10,000 from both sides. And so I have negative 4,000 P is less than negative 12,000. Divide both sides by negative 4,000. Doesn't really matter which side you move the P onto, because now when I divide by negative, it becomes P is going to be greater than 3. So when the price is greater than 3, the quantity demanded will be less than the quantity supplied. Okay, so determine the prices for which the quantity demanded. So any amount, the prices that are any amount more than or greater than $3 is where the quantity demanded will be less than the quantity supplied. So if they charge more than $3, they're going to have leftover hot dogs. Which leads us to the next question. What do you think will eventually happen to the price of hot dogs if quantity demanded is less than quantity supplied? So if we have a bunch of hot dogs and it's the 7th inning and it's there's still about 4,000 hot dogs, what we want to do is drop the price. So the price will drop and they'll start charging $1 instead of $3. So then people will go to the concession stands and buy the hot dogs. So that would be the answer to part C. Next, in 2002, Major League Baseball, sticking with the baseball theme, signed a labor agreement with the players. In this agreement, any team whose payroll exceeds $136.5 million in 2006 will have to pay a luxury tax of 40%. The linear function, T of P equals 0.4 times the quantity P minus 136.5, describes the luxury tax T of a team whose payroll is P in millions. What is the implied domain of this linear function? Okay, the implied domain here, looking at this function, I have T of P equals 0.40 times P minus 136.5, okay? And the luxury tax is only on any team whose payroll exceeds $136.5 million. So if a team has a payroll of 136 million instead of 136.5 million, then they don't have to pay any luxury tax. So here, my implied domain are all p-values that are less than or equal to 136.5. Remember, p is representing millions of dollars. So it could be equal. It's when it exceeds this number here that that's when the luxury tax kicks in, and that's when we would use this function. So I could set this up in set builder notation. So it's all p-values such that p is less than or equal to 136.5. I'm sorry, this should be greater than. Should be greater than. So all p-values that are greater than 136.5, that is when we're going to kick in and use this function, right, to determine our luxury tax. So another way to write this, if we're using interval notation, is 136.5, comma, positive infinity. And again, I made another mistake. I apologize. This should just be less, should be greater than, right? It's so only when it exceeds. It's okay if the salary equals 136.5 million. It's when it exceeds it that the luxury tax kicks in. So, all right, this is our final implied domain. Anything that is bigger than 136.5 million. All right, sorry. What is the luxury tax for the New York Yankees, whose 2006 payroll was $171.1 million? So I want to, remember, P is representing the price or the payroll in millions of dollars. So I'm going to evaluate my function T of P for 171.1. So I'm just going to plug that in here. 171.1 minus 136.5. Okay, so I have 0.40 times 171.1 minus 136.5, which is 34.6. Okay, and 34.6 times 0.4, or 40%, is 13.84. So the luxury tax for the Yankees in 2006 was $13.84 million. So that's how much they paid in luxury tax that year. Part C asks, what's the payroll of a team that pays a luxury tax of 11.7 million? So that means the luxury tax amount, the function amount that they paid, was 11.7. And so now what we want to figure out is what their payroll was, where P is represented by, or where P represents the payroll amount in millions of dollars. So first thing that we do here, I have 40 times this quantity, so I kind of want to get rid of that, I'm sorry, 0.4 times this quantity, so I want to get rid of that 0.4. So I can divide both sides by 0.40. And so 11.7 divided by 0.4 equals 29.25. So now I have 29.25 equals P minus 136.5. And now I'll add the 136.5 to both sides. And so 136.5 plus 29.25 is 165.75 equals P. So remember, what's P representing? The payroll of a team in millions of dollars. So the payroll of a team that pays a luxury tax of 11.7 million is $165.75 million. All right, moving on to the last problem, number 44. it says you have r of x equals 12x, c of x equals 10x plus 15,000. Find x so that r equals c. So we would just set these two functions equal to each other. So 12x equals 10x plus 15,000. I'll let you solve that on your own and determine the value of x. And then finally down here, find the value of x such that r of x is greater than c of x. So here we'd have 12x is greater than 10x plus 15,000. And so again, you would just get your x's together and you'd have a final statement and inequality there. All right, so hopefully that was helpful. And if you still have any questions, I'll answer those when we're in class on Monday. And have a great weekend, and I'll see you then. Have a good night.